In this video, we will continue with the iterative process. You will find this on page 555 in the Namibian AS-Level Mathematics textbook, y equals mx plus c to success. Let's look at another example. By sketching a suitable pair of graphs, show that the equation has only one real root. That's how we did it in the beginning of the chapters. Now we just throw everything together in one question. Okay, so let's start with the graph. So you first have to break it up into the two equations. So y equals 3e to the power x, y equals 8 minus 2x. Now just be careful if you draw this graph. Always know how an exponential graph looks. An exponential graph is like this. Now if the line was to this side, then you must concentrate to make it long enough. But luckily the line is a negative gradient, it's to this side, so that will not be a problem. So in this case, I'm just going to say 4 and 0 and 0 and 8. I basically just see where it cuts the x-axis and where it cuts the y-axis. That will be enough. And then I can see the root will be there. So there is only one point of intersection in this, so there is only one root. That's what they want in the first one. So verify by calculation that this root lies between 0.7 and 0.8. Now, I'm just going to take this, take everything to one side, make it fx, substitute 0.7, take note the answer is negative, then substitute 0.8, take note the answer is positive, and then, therefore, the change of sign indicates the presence of a root between 0.7 because it changed from negative to positive. Okay. And then, show that this root also satisfies the equation. So, it's actually just that we manipulate this equation, this original one there. So, basically, I'm just divide by 3 and then I convert from exponential form to logarithmic form. Okay, and remember E is ln, and then I just swap the sides. Okay, so basically it's there, then ln, and then that is my two sides that I basically just swap. Okay, and then use this iterative formula, this, to determine the root correct to 3 decimal places. And so it's 3 decimal, but all the results of the iteration must be to 5 decimal places. Okay, so again, I just put it in a table, but it's fine, you don't have to. You can basically just write it in a row. So this is x1, then x2, don't forget to this. I just want to see if they didn't give it to you, I take the middle value. Okay, so in this case, the middle value is 0.75. Okay, and then and program that 0.75 in your calculator by pressing 0.75 equals, and then put in your formula. So ln bracket 8 minus 2 answer, okay, divide 3, close the bracket. Okay, I think can I just give you a hint? In this case, just put a bracket there. Otherwise, it's just going to take that 2 terms and divide it. So I'm just going to test it quickly for you. So sometimes a bracket just help you to help the calculator. So remember, it's 0.75 equals. Okay. Then start with the formula. Ln, make the big bracket, and then make the small bracket, so 2 times open bracket. Then 8 minus 2 answer, close the small bracket, divide 3, close the big bracket, equals. And there it is. Okay. So, and then just press equal to get that one. And then press equal again. And every time I approximate it to this 3 decimal places, write it. And as soon as I see my answer are the same, then yes, and then take that answer. It converges to 0.768. And that's so actually this question is just from putting everything together. Okay. I want you to stop the video and I want you to do number 2. I just wanted to do a little bit of a ln. There was an E, so I think a ln one will be now nice to do. Okay, and this is typical exam questions. Again, you can continue the video as soon as you are finished. Okay, so by sketching a suitable pair of graphs, show that the equation, Okay, and I always like first, it's number 2, to write it down. 3 ln x equals 15 minus x3. Has exactly 1. Now, the nice thing is if they give it to you on 2 sides, they help you a little bit. It's a bit more challenging if they give it to you on one side and you have to take over and then break it up. But I think this was nice. So you can just make one graph y equals 3 ln x, and you can make the other graph y equals 15 minus x3. Again, you must know your ln graphs. You must know already how your log graphs, your ln graphs. You must know it's something like that. So I will not choose negative values. It will not work. I will not choose 0. It will not work. Okay. But I can maybe, there's going to be 1, but I can take maybe 0.5. So if I start with my table in this case, I'm going to just take, okay, I'm just going to like to create a table, and it's just so that I really can see the picture. I'll see how many I'm going to take here. And the same here. Also going to check. This is a cubic. Now, again, if you think of cubic, okay, I'm on the straight lines now. I'll show you now. If you think of cubic, then you must think again. It's usually say something like that or whatever. But that's usually that a cubic. But a cubic can also, but because there's not an x squared, it will not go to this. It will rather just go to this. Okay, but the table will help you. So let's just start. This is x, this is y. So I know that there's not going to be a 0. But I can maybe, just to go a little bit closer, 0.5. And then definitely 1. And then maybe 1.5. And then according to this one, I will actually choose this one. Because I will go a little bit, I'm going to choose it 3. 2 will also work, but I think 3 is nice for me here. So again, just press in your calculator. So it's 3 ln 0.5. That's what I do. I just showed you the first one. And make it to one decimal place. So it's negative 2.1. And then as soon as I put 1, I'm going to get 0. And then I'm going to say, I just want to say times. I'm just checking that first one. I did that. I just want to, okay. Then 3 times ln 1.5 equals, and that's 1.2. And then the last one, 3 times ln, you could have made it, also make it 2. I just made it 3, and it's because I will go up to 3 here. So sometimes you will add 1 just to get your picture. So 3, and that's 3.3. I just want to see if it was 2. So 3 times ln 2 equals 2.1. Yes. Okay, we could have even put 2, but it's fine. Okay, I'm going to just take another color here. Let's just go for X and Y. Now, this one, I think although this will just be on this side, so it's actually not necessary on that side, but just to get this shape a little bit more, I'm going to take a bit to that side. It's 1, 2, and because I did this one, so I could have made this, put the 2 also there. And if I was making a 2, I saw my answer was there, 2.1. Okay, doesn't matter if I really want to include that. So this one, I'm just going to say y equals, I'll just show you the first one. Just be careful for that negative, it's a 3. So it's 5. If it's 3 negative signs, will stay a negative. So it's 15 plus 1, and that's 16. And if it's 0, it's just 15. And if it's just 1, so if I put a 1 there, then that will be 1, and then it's minus, and then it will be 14. Okay, maybe this one I can show you again. So y equals 15 minus, let's just move a little bit to this side, and then it's 2 to the power of 3. So it's 15 minus 8, and 15 minus 8 is 7. And this is y equals 15 minus 3 to the power of 3. And that's 15 minus, remember 27, and that will be negative 12. Okay, now I can start with my sketch. So by sketching, so they want that sketch. Remember, take a ruler, make 1 centimeter blocks. Now, this is my 1 centimeter blocks. I'm just going to show you. It's not exactly, but it's the same principle, the 1 centimeter. So, okay, so just that it's a bit on scale. Now, I'm just going to draw my axis. Okay, so it's not a lot of negative. Ooh, please, just work with a ruler. Let's just get my ruler. Okay, and I'm just going to see that I do it here. Okay, and then I'm just going to fill it in. Okay, now because I go up to so high there, that's why I'm going to go for 5, 10, 15, 20. And that's going to be -5, -10. I think we can stay to a -1. There's 0. There's 1, 2, 3. I think it's only up to 3. I think that's good enough. If you want, you could have made it 1, 2. Let me do it rather like that, just because my sketch will be better. So, because it's not so, as long as if I make that negative, then I must go 2 blocks. The y-axis and the x-axis can differ, but here the multiples must be the same. So it's 1, 2, 3. Okay. So let's start plotting. Let's plot my yellow one. So it's 0.5. It's actually nice because now and it's -2.1. So approximately there. And then 1 at 0. And 1.5 and 1.2. So 1.2. Okay. And then 3. Oh, this was jumping to 3. Okay, remember 2 was 2.1. Okay. But 3 was 3.3, so it was a bit higher. Okay, maybe too high there. Okay. And if I draw it, remember, it's a curve. It's just now a little bit lower. So this is y is equal to 3 then x. Okay, now let me start with my green. So it's -1 and 16. And 0 and 15. And 1 and 14. 1 and 14. A little bit lower. And then 2 and 7. 2 and 7. There. And then 3 and -12. Oh, so there will be -15. So 3 and -12, say there. Right. So do you see my curve? Oh, you can remember. But it would have been going and there. Right there. Okay. So it's going to, this would have go up. And then it's just going to go like that. Okay, and that will be y is equal to 15 minus x3. But it's very clear, because this one comes here, that one goes up there, that it will only intersect that one time. So I can go and say, by sketching a suitable, show that the equation, okay, you can something there for 1 point of intersection. So only one real root. Okay, something like that. Okay, that's all they want. Please label your sketches. And as I said, it's just make your 1 centimeter spaces. In this case, you could have made it 2 centimeters just to stretch it about out and choose your scale. I think you're good at this stage doing this. Okay, let's go to number B. I just want to get my grid again. Not so many lines. Okay. Now, okay, I'm going to do here number B so that I can show by calculation that the root lies between 2 and 2.5. Okay, let's just do. So number B, going to do it still here. Okay, so what is fx? So fx, I must just take everything. So there is your first, and bring the other one over. So it's going to be plus x3, okay, because it's going over, minus 15. There. And now I substitute that root. So if I substitute that root 2, and I just take my calculator, and I say 3 ln 2 plus, that's 8, or 2 to the power of 3, you otherwise minus 15. And keep to 3 significant, negative 4.92. Just take note, it's negative. And then if I do the other one, f, and now I'm just going to substitute 2.5. Then it's going to be 3 ln 2.5 plus 2.5, 3 minus 15. And if I correct the 3 significant, or 3, yes, 3, but just take it's positive. Can you see it change in sign? And now I say, therefore, I just want to take red. Therefore, the change of sign indicates the presence of a root between x is 2 and 2.0, 2 and x is 2.5. That's enough. Okay, then now I'm just going to do number C. Okay, let's start with number C. Now at number C, let's just read the question. Let's go back to get that line away. No, it's not going away. Okay, use the iterative formula. Okay, and just take note there stands a 3. To find the root correct to 3 decimal places, give the result of each iteration to 5 decimal places. Now remember, they don't tell you the starting point, but they told you the root is between 2 and 2.5. So you can take 2, you can take 2.1, 2. But the middle will be 2.25, but I think rather take it 2.3. Okay, let's try. It's not going to have an influence. So x1 is 2.3. Okay, now this time I'm not going to create a table because you can just do it in a line. So x, and now I'm going to start n plus 1, and please don't forget that that is a 3. It's a cube root. Okay, and it's 15 minus 3 ln x n. Okay, now this time, as I said, I'm just going to write it in a row. So to get x2, but first let's program your calculator. So make 2.3 equals. Now it's in your memory. Then start. It's a cube, so if I go shift and I press the cube root. Okay, it's on top of x3 on my calculator. Then bracket 15 minus 3, and now it's ln, first ln, and then answer, ANS, close the bracket. I don't think that's important. I didn't press the multiply. It will directly go, but equals. And I get 2.320. Remember, every time they said it must be to 5. So 1, 2, 3, 4, 5. So 8, 7. 3, 2, 8, 7. 8, 7, because there's a 3 after the 7. And if I approximate it to 3 decimal places, it's 2.321. Okay, let's go on. Now, just press equal. I get 2.3191. Now it's 1, 2, 3, 4, 5. So after that 9 is a 4. So it's 1, 9. So 1, 2, 3, 4, 5. So that after, just make sure it must every time be 5. So after it's a 4. And if I approximate it to 3, underline, so it's going to be 2.319. Okay. And then I'm going to go for x4. So press equal again. So it's 2.3193. And now it's 1, 2, 3, 4, 5. So after the 2 is a 9. So it will become another 3. And if I approximate it to 1, 2, 3, it's 2, oh, and that's nice. There I see it start repeating. Okay, that's where the yes was always coming. So therefore I can just say correct to 3 decimal places. X is equal to 2,319. So just take note. You could have also taken 2.4. You could have taken 2. You could have taken 2.1. Sometimes you will just get a step extra, but at the end it will convert to the same answer. And that's how you do it.